Hello, dear students. This is Professor Ramanandan HS, Department of Mechanical Engineering, Assistant Professor, Maharaja Institute of Technology, Mysore. Today, we will be spending our time on the subject Fluid Power Engineering with the subject code of 18ME 55. Contents of today's discussion are cylinder cushioning, problem on cylinders and gear motors. So far, just to rewind or recap, so far you have studied more of the concepts of hydraulic cylinders. So cylinders which is consisting of a piston just to pressurize the fluid. So function of a cylinder is to pressurize the fluid from one point to another point. So next consideration is usually the cylinders are subjected to high pressure, because obviously we know hydraulic fluids are nothing but in a confined, so as Pascal's law say, if it is a confined fluid which is applied with a certain pressure inside a cylinder consisting of a certain volume or an area, so there will be pressure being built up because of the application of external pressure on the cylinder surface or cylinder area or volume of a cylinder. So in order to compensate such pressure which is existing inside the cylinder because of the hydraulic fluid, so there is a concept called as cylinder cushioning, cylinder cushioning, because the oil which is getting pressurized inside the cylinder has to be in one or the other way need to be controlled. In every system there is called as a control system, because if you see the fans, fan, though it is a open control system being operated by manually, these days we find smart fans. It will sense the need of the benefited person sitting next to the or nearer to the fan in the proximity. So it can operate on its own because of the smart devices being employed in the fan. But in the domestic fans, ceiling fans, whatever we see, so you have something called as a regulator, which will usually cut down the voltage, or provide a resistance to the current, so that the speed of the fan is being brought down. So power is nothing but the product. All these things you have studied, it is a product of voltage and current. Similarly, if I reduce the current, obviously, or current is reduced in the form of resistance to current. So power comes down, the power supplied to the fan comes down, so that the speed of the fan gets reduced. So similar mechanism is what is employed in cylinders. Solution exists in the problem itself. That is what we have been told so far. If you understand and observe the problem carefully, the solution is there within the problem. It will be giving a hint to us. So hydraulic cylinder, as I said, that the oil which is being confined in the cylinder is applying the pressure on the cylinder. The solution is there within the oil itself. By just making a certain arrangement to the oil, I can control the pressure inside the cylinder with the help of hydraulic fluid only. So how can you do that? How can you do that? With the same hydraulic fluid which is applying the pressure to the cylinder, how do you take the advantage of decelerating its own piston speed and thereby controlling the pressure? So that is a concept called as cylinder cushioning. You can just see a pictorial representation here. So it will help us in understanding the concept. So you can just see from the outside to inside. Let us go from outside periphery to inside. So this is the cylinder. You can see the piston here. This is the plunger rod, what you see here. This is a very important area which is applying the pressure to the fluid. Effective area of the piston is measured by the plunger surface being exposed, as well as if you are reversing the direction on the rod side, as well as piston surface area. There is something called as cushion chamber here being provided for the cylinder cushioning, and you can see a port here, port for output port. This is the output, and oil is confined here within the cylinder. So this is a double-ended cylinder. You can see the plunger rod where it can extend and retract. Okay, it can extend and retract. So from both the ways you can allow the fluid. You have already studied the cylinders. This is a double-ended cylinder. Okay, from both the sides I can reverse the direction. I can provide the forward direction movement as well as the retraction cycle will provide us the backward direction of movement of the cylinder. So you can see something called as a check valve here. Okay, check valve function is to allow flow in only one direction. Okay, allow flow in only one direction. Right now you should know just the parts and their function. I will tell you the working later. Okay, check valve function is to allow flow in only one direction. Needle valve. So needle valve I have written here, it sets the deceleration. Okay, it sets the deceleration. So this is about the parts of cylinder cushioning components. So how a cylinder functions? Now just rewind to you. So there is oil here. Okay, pressure is applied with the help of a piston in this direction, in the forward direction. So you can see here, so flow takes place in this direction. So oil flows out continuously through the port and the plunger rod keeps on moving till where? Till the cushion chamber, because plunger rod comes and occupies this cushion chamber. So there the movement of piston stops, and cylinder is having the highest pressurized condition because of the fluid. But you can see here these small openings are provided here on the either two sides. The openings here, the openings here, what does it do? So there is a, just imagine, I am writing the sketch again. Your cylinder, plunger comes till here. Plunger comes till here, and then there is a small space available like this. So there is a small space and your needle is so adjusted that the amount of fluid starts to flow through this small opening now. The remaining fluid starts to flow through here, and it will in turn slow down the movement of plunger rod here. I repeat, the small opening being provided by the setting of needle valve. Needle valve is adjusted manually so that the small opening, whatever the amount of opening you require by calculating the what pressure is the safe pressure to the cylinder, you can set the needle valve. So needle valve will allow, once the plunger rod comes and occupies entire cushion chamber, whatever the small space which is remaining here, so from there the fluid starts to flow and it will block the apply pressure on the plunger head, and it will still give the slowing down effect or deceleration to the entire piston rod. So thereby it avoids the impact load of piston to cylinder with a high pressure because of fluid from here, because of fluid acting on the piston surface. So piston will be getting rammed to the cylinder. So that is what we are trying to control with the help of hydraulic fluid only. The same hydraulic fluid with the help of needle valve will again push down this plunger with a certain pressure, and it will slow down the rupture of piston or ramming of piston to the cylinder, thereby acting like a cushioning, so that your piston doesn't ram at the end cap. It will slowly come down and halt at the end cap region or cylinder end. Cylinder end will slowly run. So you can reverse the direction. How? Now the cylinder plunger has to move to its original position. That provision is provided with the help of something called as a check valve. So from here again the fluid can be allowed to flow. Check valve provides one directional flow of the hydraulic fluid. So check valve will allow the fluid to flow so that your piston is under full flow condition, and with the help of excess fluid from the check valve, and your piston comes to the original position inside the cylinder. So now main intention of providing cylinder cushioning, now you might have understood. So to avoid rupture of cylinder on the end caps nearer to plunger, we don't want the plunger to get damaged, because that is the main area of cylinder pressure building surface, which is always in contact with the cylinder. Piston is always in contact with the cylinder. So, we do not want the ends of piston to get damaged because of the maximum pressure sustained within the cylinder. So, this is the graphical symbol of the cylinder cushioning. So, you have understood the objective and components as well as working of hydraulic cylinder cushioning. Next topic is usually we have taken, we will go back to problems on cylinder at the end of the session. So, we will not touch the portion because if your objective is completed at the end, so if you know the concept completely, we will touch the problems on cylinders later. So, right now we do not focus on this, we will go to gear motors. Once the cylinders are understood, we will go to motors classification. Because I have not written there is the purpose, because you have studied already the pumps. Pumps are nothing but where the we use mechanical energy to get converted into hydraulic energy. Pump function is to gain the torque from electric motor and start rotating, create the from the low pressure oil, generate a high pressure oil and pump it to the motors. I repeat, its function is gain the mechanical energy from motor, say electric motor, and then with the help of hydraulic fluid create a suction and discharge it at a high pressure to the next segment called as hydraulic motor. So, pump function is to convert mechanical energy into hydraulic energy. So, opposite to this is nothing but the hydraulic motor. So, why there is so much of conversion? Because you cannot directly get the extraction of hydraulic energy. So, it has to be from low pressure to high pressure and then spend the same oil from high pressure to low pressure, so that you get amplified torque at the end. I want reciprocating movement or rotary movement that is not directly extracted from the hydraulic oils. A very tough job. That is why as mechanical engineers, our job is to transmit force, energy and power. So, in order to do that, so we have to do a lot of exercises on naturally available source of energy. This is what in the introduction session we have been mentioning. I am just reminding you so that we get connected to the topic. So, hydraulic energy is right now ready from the pump, from the pump. It has to be spent on motor now. So, motor's function is to take hydraulic energy as an input, give out mechanical energy as an output, or simply take hydraulic energy, high pressure oil inside the chamber, say suction chamber, and discharge low pressure oil, taking high pressure oil and discharging low pressure oil. What is the consequence of this? It is being spent on the rotor of the motor, say shaft simply. That shaft will take this pressure energy of the oil, so that pressure energy is converted into torque or rotational movement of the shaft. So, in order to get this objective, we have been working so far. So, hydraulic motors, again classification is something similar to the pumps. So, you have gear pumps, say displacement. When it comes to displacement, fixed displacement and variable displacement. So, under fixed displacement, say displacement, you already know, volume of fluid being discharged by the motor. So, that is called as that is related to displacement. Displacement is nothing but the movement of piston, or it may be the elements whatever you use. So, from there it is measured. So, simply to understand volume of fluid being discharged outside. So, that will give us the displacement. So, always these are all fixed displacement pumps, motors, fixed displacement motors, gear motors, vane motors as well as piston motors are there in our academics to study. So, we will understand in today's session about gear motors, because similar to there, gear pumps, vane pumps and piston pumps, there we have already studied. Here also gear motors, vane motors and piston motors. In gear motors you have, okay, you had classified there as external gear pump, internal gear pump, and a special case in internal gear pump called as gerotar. Okay. Here also same thing in motors, gear motor, vane motor, okay. So gear, okay, in gear it is external, internal and, okay, gerotar, or we sometimes we say orbital gerotar motor, okay, just small change in naming the motors. Okay. In vane we have studied balanced and unbalanced. Here also same thing, balanced, unbalanced type of motors. Again in piston motors you have fixed displacement and variable displacement motors. So in fixed displacement motor you have, okay, swash plate design and oval plate design motor. I repeat, under piston motor, fixed displacement and variable displacement. Fixed displacement has two types, swash plate motor and oval plate motor, okay, similar to pumps. Next is variable displacement type of piston motors. In variable again you have two types, swash plate design and bent axis design, okay, and last one is radial type of motors. So if you study all of them, you will get a brief picture of fundamental concepts of motors again. So it is just a recap of pumps you have studied, but the conceptually happenings are different, okay. So that you should be very careful. So we will enter into first one, gear motors. I told you gear motors are fixed displacement motors with a, okay, pressure range of 2000 psi, 2000, okay, pounds per square inch. That is the pressure range of, okay, external gear motors. So it will operate at a very high speed, say 2400 rpm, in the range of 2000 to 2400 rpm. That is the shaft speed what you can get, okay, the shaft speed what you can get from the external gear motors, okay. So the components to name, you can see from outside to inside. So this is the casing, okay. So this is the internal housing what you see here. So this portion is, okay, housing, okay. So these two are the gears, okay. One is the driver gear and driven gear, okay. You can see the teeth profile plays a vital role here. Usually spur gear is what is being used. So these are the shaft, okay. This is the inlet, so this is the inlet and this is the outlet, okay. So this is the high pressure oil chamber, obviously inlet, and this is a low pressure spent oil, low pressure oil chamber. So from here, okay, from here, so this is from pump, okay. From pump, high pressure oil enters the inlet of, okay, motor, enters the inlet of motor. So you can observe here the teeth nearer to the housing, okay, these two teeth, they have, okay, they are under more pressure initially because of high pressure oil entering and acting on the, okay, this part of the suction chamber, okay. So the net torque is balanced because of the flow taking place across the housing. The flow is taking place this way, the flow is taking place inside, okay, inside the housing, here inside, between the teeth and the housing, okay, flow is taking place between the teeth and the housing. So net torque is usually balanced because of the rush of oil. So usually there is, okay, side loading and, okay, normal loading acting on shaft and bearings of the motor. So that, okay, pressure load or normal load and side load is usually balanced because of net torque acting on both the teeth. Here also these two teeth are usually at a low pressure, teeth at low pressure, and these two teeth are at high pressure. So they usually, okay, compensate the net torque, because here the net torque is low, here the net torque is high. Because of this, okay, the balance is achieved on the shaft and the load is usually compensated off. Okay. The oil enters here and travels through between the space of teeth and the housing inside, and the spent oil goes out through the discharge oil, and the pressure energy in this activity is being converted into mechanical energy of the motor, say rotation of the shaft. Okay. So, I repeat, motor's objective is to convert hydraulic energy into mechanical energy. So, where does the hydraulic energy come from? From the pump. So, pump has the pressurized oil at high pressure, that is being fed here at the inlet. So, and it travels through between the teeth and the housing of the gear motor, and low pressure oil flows through the outlet, and the pressure energy what is spent in this activity on the teeth, it is transferred to the rotor, say shaft. So, that shaft will gain the whatever spent pressure energy and gain the mechanical energy at a very amplified speeds. So, this is being used as mechanical energy in it may be used as a reciprocating or rotational motion of the in the final output end in any hydraulic devices. This is about external gear type of motor. So, internal gear motors. So, you have already studied external gear motors. You can see meshing of gears here takes place externally. Gears, they mesh externally. So, between the teeth, whatever the profile of the teeth is there and the space between the teeth, they are meshing externally. The name itself will indicate so many things to you. So, internal gear motor. So, that means to say gears are mounted in such a way that one gear is mounted with a inside gear. Internally one more gear is present within the housing. So, you can see just an example. So, this is the main shaft, whatever you see here. So, inner gear axis, and there is eccentricity, eccentricity between the two gears. They are not concentric, they are not on the same center, they are mounted with a small difference in their centers. So, that is because there is a reason. The external gear has one teeth more than that of internal gear. Always you should remember, very important thing, the external gear has one tooth more than the internal. Always this should be remembered here. For this purpose, there is eccentricity being provided, as well as one more objective of eccentricity is the space between this internal and the outside gear, inside gear and the outside gear, that is utilized for the oil to occupy. That is called as pocket or suction chamber or discharge chamber if it is on the outlet port. If it is on the outlet port, we call it as discharge chamber. The pocket which is existing because of the internal gear having one tooth less than that of external gear, that is called as space, is called as that annular space is called as pocket or chamber. So, internal gear tooth has one tooth less than that of external gear, or external gear has one tooth extra or one tooth more than that of internal gear. That is why it is eccentrically mounted, so that there is a space existing between internal and outside and inside gear. That space is nothing but the suction chamber. Function remains same. So, high pressure oil enters into the inlet chamber. Say it will be usually a kidney shaped pocket. So, that is filled with the high pressure oil. So, high pressure oil travels between these two gear space when the shaft starts rotating, and then spent oil flows through the outlet port. It will discharge this pressure energy to the shaft. So, the shaft gains the mechanical energy and it will rotate at a very high speed. So, this is a simple function of internal type of gear motor. I repeat, so in internal gear motor, the inside gear has one tooth less than that of outside gear, or external gear has one tooth more than that of inside gear. They are eccentrically mounted. So objective of eccentric mounting of gears is because, so you can see just here, centers are not aligned. Eccentricity is nothing but their centers are always, okay, not same, not a concentric gear. They are just mounted with the offset distance. So that distance will create the chamber between the gears. So that chamber is nothing but provided for the hydraulic fluid to occupy. So high pressure oil occupies that space from the pump, okay, that will spend the pressure energy between the gears, and it is transferred to the rotor or the shaft. So that shaft will rotate at a very high speed. Spent oil will go through the outlet at a very low pressure. So this pressure energy of the oil is utilized to, okay, for the rotation of the shaft. So that will give you the mechanical energy. Okay. Similar to this is the gerotor motor. We have already studied in gear pumps. So that will also function the same way. So gerotor motor is easily understood as an orbital motor in a similar fashion. So hope this session has okay, reached you appropriately. To give a brief picture, we have studied the cylinder cushioning. Okay. Objective of cylinder cushioning is to avoid the rupture of cylinder and okay, piston, protect the piston end cap by providing a small geometrical solution within the cylinder with the help of needle valve, small ports, okay, as well as the check valve or the ball valve. Okay. Then we have studied the classification of motors similar to pumps. Motor function is to convert, okay, hydraulic energy into mechanical energy. That was our core objective. Okay. In order to pursue that, we have used a pump, then again a reconversion, convert the hydraulic energy into mechanical energy with the help of motor. We have seen different classification of the pumps. Further, in the subsequent classes, we will start discussing on vane motors and piston motors. Okay. So thank you.